Hi guys, welcome to the second lecture of chemistry. Till now, we have discussed about application and the importance of chemistry. And today we are going to discuss about the laws of chemical combinations. Now, one day a person was sitting under an apple tree and this happened. The name of the person was Isaac Newton and he gave a law, and the name of the law was law of gravitation. According to this law, two bodies attracts each other by a force of gravitation, and that force is directly proportional to the product of their masses, and also it is inversely proportional to the square of a distance between them. So what I want to say, whichever phenomena is occurring on the earth is governed by a law. Similarly, in chemistry also, the reactions taking place and the formation of the compounds are also governed by certain laws, and those laws are called laws of combinations. Let us discuss those laws in detail. And the first law is law of conservation of mass. Now this law was given by Lavoisier. Lavoisier was a French scientist and he gave this law in 1774. He said that during any physical or chemical change, it means whether there is a physical change or there is a chemical reaction, the total mass of the products remains equal to the total mass of reactants. Means the mass of the reactants which are reacting will be equal to the total mass of the products which are formed in the chemical reaction. He demonstrated one experiment also. He demonstrated the experiment on mercuric oxide and he said that if 100 gram of mercuric oxide decomposes, it will give us mercury and oxygen, and weight of mercury will be 92.6 gram and oxygen is 7.4 grams, and you can clearly see from here 92.6 gram plus 7.4 gram is exactly equal to 100 grams. It means that mass can neither be created nor be destroyed. He also gave this law, that law of conservation of mass is also known as law of indestructibility of the matter, means matter cannot be destructed. So this was given by Lavoisier. Now guys, next law was law of definite proportion. So that is the law, and this law was given by Joseph Proust. Joseph Proust, he was French scientist and he gave this law in 1799, and he said that a chemical compound always contains same elements combined together in same proportion by mass. Let me explain you what he want to say. Let's take an example. Now it can be shown experimentally by the different sample of CO2. Now, irrespective of the source from where the CO2 is coming, if we take the ratio of the masses of the carbon and oxygen, that will be always and always equal to 3:8, right? Let's see how. We know that the formula of carbon dioxide is CO2. Okay? Mass of carbon is 12 AMU. Now this is the atomic mass of the carbon. And if I talk about oxygen, the total mass of the oxygen will be 32 AMU. And if we take the ratio of 12:32, it will become 12:32, it will become 3:8. And this 3:8 will be always applicable for CO2 irrespective of the source. Let's solve one problem based on this. Now guys, in this question he is asking copper oxide was prepared by two different methods. It means that copper oxide is prepared in two different experiments. So in one case 1.75 gram metal, so copper was 1.75 gram, gave 2.19 gram of oxide. In second case, in other case, 1.14 gram of copper gave 1.43 gram of its oxide. And he is asking us to prove, show that the given data illustrate law of constant proportion, means we have to prove the percentage of copper and oxygen in both experiments, or you can say the compounds we got in both the experiments are same. Let us solve this question. Now, first what we have to do, we have to find out the percentage of metal in case number 1. So, case 1, the weight of the metal is 1.75 gram and 2.19 gram of oxide is there. So the percentage of the metal that is copper will be equal to 1.75 1.75, that is the weight of the metal, divided by 2.19 multiplied by 100, and that comes out to be 79.9%. So this is the percentage of copper present in copper oxide we got in the first experiment. Now, if we want to find out the percentage of oxygen, the percentage of oxygen that will be equal to 100 minus 79.9, and that will be equal to 20.1%. So, in case number 1, you can see here, copper oxide was prepared by two different methods. So, in first method, we are getting 79.9% of copper in that particular copper oxide and 20.1% of oxygen in that copper oxide. Let's find out the percentage of copper and oxygen both in the second method. So, first we have to write the weight in the second method. So, in case 2, what we have to do? First we have to find out the percentage. So, how much copper we were getting? The weight of the copper was 1.14 gram. Therefore, the percentage of copper or metal you can say, that is equal to 1.14 divided by 1.43 into 100. So 1.14 divided by 1.43 into 100, and that comes out to be 79.8% approximately. And if you find the percentage of oxygen, that will be the percentage of oxygen, and that will be equal to 100 minus this 79.8, and that is equal to 20.2%. Right guys, now just see that in first case we were getting the percentage of metal, the copper, it was 79.9%. Now we are getting, by the second method, we are getting 79.8%. So it's almost same. That means the law of definite proportion is surely applied in this case. Let's move on to law of multiple proportion.